Good morning. So I said yesterday that we were going to go over the homework from yesterday today, but I also forgot that the way I've set up my other classes, I'm going to do that with this class too. So what we're going to do is you have homework yesterday, homework today, homework tomorrow, and then when we're all done with the lesson or the section we're on, we're going to do not the whole lesson. We'll do like 3 homeworks. We'll do a review day where I go over all of these homework problems in just one lecture rather than wasting time right now with the homework. So we will go over the homework from yesterday on the review day, which will probably be on Friday. Okay, so remember yesterday we started talking about vectors again. We looked at all the different types of vectors versus scalars. We looked at how we can represent vectors, and we saw that we could use vector diagrams in order to represent vectors. Remember, we use north, south, east, and west, but there's this special convention, which is the counterclockwise from east convention, that is very important and that we're going to be using a lot. Remember, that's where we start at east and we go counterclockwise from east, and we calculate the angle in that way. We looked at vector addition. Remember, we can add vectors in the same direction, which we've done before. We can add them in the exact opposite direction, which we've also done before. But now what we're doing is adding vectors that are not in the same direction. And we're going to see that we're going to be adding vectors that make right angles. Well, not always right angles, but mostly right angles together. Okay, so the 3 methods that we have for solving for the resultant when the vectors are not either in the same or exact opposite direction. Yesterday we talked about the Pythagorean theorem, and today we are going to talk, yesterday we talked about this, today we're going to talk about the trigonometric method, and very slightly going to talk about the head to tail method. So we talked about the Pythagorean theorem method yesterday, and remember this one, I think I said it, but I didn't write it down. You should write this in your notes. This is used to find the magnitude of resultant. So we can't use this to find the direction. We can only use this to solve for the magnitude. If you remember yesterday and from your homework, you saw that we were only solving for the magnitude, right? We weren't figuring out this angle, like what direction we're going in. We only solved for the magnitude of the resultant. So today, what we're going to see, we're going to look at the trigonometric method, method number 2. Oh, there we go. So this is method number 2. And it is the trigonometric method. And we are going to use this exclusively in order to find our direction of the resultant, not the magnitude, just the direction of the resultant. All right, so this can also only be used when our vectors that we're adding together, are at right angles to one another, exact right angles to one another, and it's very important, and we can only use this, can only be used when there are only 2 vectors. So if we have 3 vectors, just like yesterday we can't use remember yesterday I said we can only use this, the Pythagorean theorem method, when we have only two vectors and when those two vectors are at right angles to one another. Well, the same rules apply to the trigonometric method. We can only use this when we have two vectors that are exactly right angles to one another. Okay, so if we have two vectors and they are at right angles, we can use SOHCAHTOA. SOHCAHTOA. Right? This is trigonometry, which you've definitely done SOHCAHTOA before. SOHCAHTOA. So what we have here, remember, let's just draw a triangle real quick. It has to be a right angle here, like this in this situation. Well, to use the trigonometric method, so we have to have that right angle. We have side A, side B, and side C. This A side is the side that's adjacent to angle theta. Oh, sorry, this is angle theta right here, theta. So this A is adjacent to theta. B is opposite of theta. And C is hypotenuse. I always spell this wrong. There we go. Okay. All right. So when we can use any of these three functions, SOHCAHTOA. If we want to use the sine function, sine, the SOH part, we're going to do sine is equal to the O opposite over the H hypotenuse. So if I want to know the sine of angle theta here, I would do opposite, which B is the opposite of theta. So B divided by the hypotenuse of this triangle, which would be C. If I wanted to use cosine, which is the CAH, you're going to do cosine equals the adjacent, which in this case adjacent to theta is A, and we're going to do that over hypotenuse, which is C. Or if I wanted to do tangent, I'm going to use TOA, which is T for tangent, equals the opposite, so B is opposite, over the adjacent, which is A. So if I do any of these three, I can find the angle, what theta is. I can find theta. I can solve for theta. So let's look at an example here. So this should all be a refresher for you, but if it's not, hopefully you're taking good notes and paying close attention. So let's look at an example. So we're going to have Muhammad Ali walking again. He is going to, it's the same one that we did yesterday. So Muhammad Ali is going to leave his house and he's going to walk 6 kilometers north. So here's his house. He's going to leave and walk 6 kilometers to the north. I do not like the way that K looks. All right. Kilometers to the north. And then he's going to turn and he's going to walk 6 kilometers to the east. 6 kilometers to the east. All right. What is the direction of the resultant of Muhammad Ali's walk? So in what direction is the resultant? So remember yesterday we solved for this. Obviously we can't solve for theta, which is right here, right? There's our 90-degree angle. So we're looking for what direction is this, in what direction is this resultant pointing? All right, so I'm just randomly going to, I was saying we need to remember, what did we do? Here's the problem from yesterday. I said he walks 5 kilometers east. Okay, so we're going to change this to 5 kilometers. He's going to walk 5 kilometers to the east. All right, and the reason for that is because yesterday we solved for the resultant here, the magnitude of the resultant, using the Pythagorean theorem method. So remember we found that it was 7.8 kilometers. So I'm going to write that here. Resultant is 7.8 kilometers. All right, so now I want to know the angle. So in order to do that, I'm just going to use one of these. I'm going to use so, ka, or toa. And either one, any one that you use is going to work. So let's just do sine. So the sine of this angle, this theta here, is going to be the opposite, which is 5 kilometers, divided by the hypotenuse, which is 7.8 kilometers. And that gives us, I forgot to write theta, so sine of theta here. There we go. All right, so that gives us the sine of the, and I guess you don't have to, I haven't done this in a while, you don't have to write out sine, you just write sin. I always forget that. Sine of theta equals 0.64. And what do I do in order to get theta by itself? I have to take the inverse sine of both sides. So I take the sine inverse of both sides. When I do that, I cancel out over here, and I get that theta is equal to, we'll just round up to 40 degrees. Okay, so that's what we've gotten here for this angle, but we have an issue here. So for every single one of these problems that we are doing going forward, we are going to be doing the counterclockwise rotation from east method. So, or convention, excuse me. So what that means is I have found this angle within this triangle. But what I need to actually find is this angle right here outside the triangle, right? So in order to do that, first I have to know this angle, and when I know that angle, I can know this angle also. And the reason I know that angle is because this is 90 degrees, right? So, excuse me, if I have 40 degrees here, how much is left to get to 90? Well, it's 50. So this has to be a 50-degree angle because theta plus this angle on the outside must be equal to 90, right? Because from between north and east, there are 90 degrees. So the correct answer here is that this resultant is in a 50-degree, I hate the way that 5 looks, and I think I have OCD, a 50-degree counterclockwise rotation of east, or from east, or however you want to write that. So a 50-degree counterclockwise rotation of east, or from east, meaning we moved 50 degrees from east in the northern, or in the counterclockwise direction. So that is the angle at which this resultant is. Let's look at one more example here. We'll just scoot over here. So in this example, we're going to have Lena walking. We're going to do 2 more examples. Lena is going to walk 3.2 kilometers to the north, and then she's going to walk 5.1 kilometers to the west. What I want to know is the magnitude and the direction of her resultant of this walk. So in order to find first the magnitude, we're going to do Pythagorean's theorem. Right? So we're going to say that 5.1 kilometers squared plus 3.2 kilometers squared equals c squared. And when I plug that in, I get that c squared equals 36.2 2, 5, that's equal to c squared. If I take the square root of both sides, I get that c equals 6.02. We'll say 0.2. All right. So we have let's just do correct significant figures here, actually. So we'll just do 6.0. Okay. So there we solved for our magnitude of our resultant. That's in kilometers. Now I want to know the direction. So I'm going to use ka, which is cosine of theta, which in this case, theta is, there's our 90 degree. This is theta right here. So the cosine of theta is equal to the adjacent, which in this case is 3.2 kilometers, divided by the hypotenuse, which is 6.0 kilometers. And I get that cosine of theta is equal to 0.53. And then if I take the inverse cosine of both sides, I cancel out and I get that theta equals the inverse cosine of 0.53, which is 58 degrees. So theta here is 58 degrees. However, we're giving our answer. We have to give our answer in the counterclockwise from east convention. So here I have east. This is just an axis, right? West, north, south. All right. So now I have this. What I have here is my angle is 58 degrees. This would be west of north, right? This angle is 58 degrees west of north. But what I want is east, counterclockwise of east. So in order to do that, I have to extend this angle all the way down here. So what I'm going to do is I'm going to add 58 degrees plus this whole angle right here. Remember, each quadrant is 90 degrees. So I add 90 degrees and I get 148 degrees east. We'll say counterclockwise of east. Let's do an abbreviation for that. Counterclockwise, clockwise. That's one word though, isn't it? Counterclockwise of east. We'll say COE, counterclockwise of east. Alrighty. One more example. Let's do one more. So we have Yusra. She is going to go for a little jog. She jogs. That is not a straight line. Yusra jogs 2 kilometers to the west. Then she jogs, let's say, 5.1 kilometers to the south. So what I want to know is I want to know the magnitude and the direction of Yusra's resultant run. So first what I'm going to have to do, I have to solve for the magnitude of my r here. So in order to do that, I have to use Pythagorean's theorem. And I'm going to say a squared plus b squared equals c squared. My a is just randomly going to be 5.1 kilometers squared. Plus b squared is going to be 2 kilometers. Whoops, I did that wrong, but you get the point. 2 kilometers squared, and that's going to equal c squared. So when I plug this into the calculator, I get 38 is equal to c squared. And let's do it exactly, actually, because these are exact values. 37.64 equals c squared. Take the square root of both sides. Square root. And I get a resultant of 6.1. So now I know the length of my resultant. I know the magnitude is 6.1 kilometers. What I want to know now is, erase this work. What I want to know now is the direction. So I'm going to just, since I've already done the sine and cosine, I'm going to do tangent, TOA. So tangent is equal to the opposite. So here I have my 90-degree angle, and the angle that I'm looking for is right here, theta. If you can't remember, like if you're supposed to do theta for here or theta for up here, an easy way to remember or to think about it is, where is the axis origin? Remember, the origin is the center here, the center point of our axis. So if you imagine this as an axis or as a compass or whatever you want, the origin would be right in the center, right? That's basic math that you definitely know. So wherever 0, 0 is, that's the place that's closest to theta. Just in case you have struggles trying to remember if it's this is theta or if the other one is theta, the one that's closest to the center of the axis is the one that is theta. So tangent is our opposite. So opposite of our theta is 5.1 kilometers divided by the adjacent, which is 2 kilometers. And when I plug, this is sine of theta. I always forget, see, I told you, I always forget to write the theta here. There we go. All right, so if I plug that in, 5.1 divided by 2, I get that the tangent of theta is equal to 2.55 kilometers. Then I need to take the inverse tangent of both sides. And when I do that, I get that theta is equal to 60, let's say, well, how many significant figures? We'll just say 69 degrees. Okay, so now remember, we're not quite done yet, and the reason for that is because this angle is just from west to the resultant, right? So that's just this angle right here. But what I really want, what I have to find, is my rotation, my counterclockwise of east rotation. So in order to do that, now I have 90 degrees in this quadrant to add, and I have 90 degrees in this quadrant to add. So I have 180 degrees to add to my final answer. So 69 plus 180 plus 69 is 249. So my angle here, my overall angle, is 49 degrees counterclockwise of east. That is the direction that we're going. Okay, so it's very important that you understand. In order to find first, let's erase that. We'll go to the next page. So in summation, when we have two vectors only that make right angles, or make a right angle, we use one, Pythagorean's theorem method, used to find magnitude of resultant. Then we're going to use the trigonometric method used to find the direction of the resultant. It's very important that we do the direction in the counterclockwise of east convention every time. All right. I was going to tell you something about... Nope, don't remember. Lost it. Okay, so this is how we're going to find our direction, our magnitude, and our direction. Very important. All the examples that I've shown you so far, all of these are like only one direction, right? Like I said, Yusra walks or runs 2 kilometers west and then north. But what if I told you that Lena, or I've already done Lena, Mariam Baba is going to go 6 kilometers to this is going to be in the, what would that be, northeastern direction. Then she walks 12 kilometers. So this is northeast. Let's just draw I'm going to draw it. I'm going to draw my axis here. So we were at north, east, south, and west. So first she goes 6 kilometers exactly in the northeast direction. That's not 100% exactly, but we're going to call that northeast. Okay? Then she walks 12 kilometers exactly in the southeast direction. What I want you to do is find the magnitude and direction of the resultant. So you might say, well, I can't because this isn't a right angle. But in fact, when we have something like this, when we have northeast and then southeast, although I can't draw it perfectly, this is a right angle. So we can do the Pythagorean theorem and method and the trigonometric method here. So don't get like, I can't do it because it's not perfectly in the west and south or the north and east or whatever it is. Because let's look at another example. Lena is going to walk southwest and then she's going to walk northwest. This right here is a 90-degree angle. The resultant is up like that. There would be the resultant, okay? So it's very important that you draw the vector diagrams out. That was what I was going to tell you, so I did remember. So you have to first draw vector diagram, always. I'm even going to write always here. Always. Okay, so these are the two methods we're going to use when we're given two vectors only, and when these two vectors are at right angles of one another. I told you that there is a third method that we can use that's called the head to tail method. Method number 3 is the head to tail method. There will be a question about this for extra credit, I'm telling you right now, on your quiz. There will be a head to tail method question on your quiz because I'm going to spend very little time going over it and there's not going to be any real homework problems. But the way that this works is if you have more than one vector, let's say you have like 5 or 10, let's say 5 different vectors. So what you would do is, most importantly, you need a scale. So this, we're going to call that 1 centimeter, and it's going to be equal to 1 meter, or we'll say 1 kilometer. Okay, so this is going to be a homework question for extra credit tonight also, so I hope you're paying attention. All right, so first you need your scale. So we can use this when there's more than one vector. Use when there's more than one. I mean more than 2, sorry. All right, so what you would do, let's say you have a word problem like Hindu starts in her car from her house. She travels 2 kilometers to the east. So you would do exactly, I'm going to literally copy it so that I make sure it's the exact same size every time. Hello. Thank you. All right. So erase that. Okay. So here she's starting at her home and she's going to go 2 kilometers. So since 1 centimeter is 1 kilometer, I'm going to do 2 like that. Then she's going to turn and she's going to travel, let's turn this, and she's going to go north for 3 centimeters. And then she's going to turn left. And she's going to travel 1 centimeter, or 1 kilometer, sorry. And this is where she gets to TLC. All right. So what we can do here, we need to find the resultant. And we're going to do that by drawing the tail of the first vector to the head of the last vector. So the tail of the first vector to the tail of the last to the head of the first. So there is the tail of the first, which is right here, to the head of the last, which is right there. Okay? All right, so then we get our R. Okay, now what we need to do is, you would obviously be doing this using a ruler, right? You would be measuring out 1 centimeter each time. So what we need to do now is use our quote-unquote ruler in order to determine how long this resultant is. That's literally the way we're going to do this. So if I line up each of my centimeters here, or not my centimeters, but my scale, if I have one, whoa. All right, there we go. I have my 3, it took 3 of my scale centimeters here, of these, in order to line up with the resultant. Obviously, this is much, much, much more accurate. If you're using a ruler, you would just measure this length, and if you had 3.6 centimeters, then you would have 3.6 kilometers, right? Because 1 centimeter equals 1 kilometer. But I don't. So let's say I measure it and I get, let's say I get 3 centimeters or 3 kilometers here. Okay, so that's my magnitude, but now I need to know my direction. So in order to find the direction, you're going to need to use a protractor, and here is your axis. Here is your axis. If you want, you can just measure this theta and then determine or add these 3 quadrants, because we have to still give our answer in east of, or counterclockwise of east convention. So you can either just add that angle, or you can measure just that angle, or if you want, you can measure this whole angle here, so we can know exactly what the direction is of the resultant. So in order to do the head to tail method, you need to have a scale. You need to use a ruler in order to make a scale. Then you need to draw your diagram with all your vectors. Then you need to measure your resultant with ruler in order to determine the magnitude. To find magnitude. Then you need to measure the angle, whichever one you want, whether it's the small one or the larger one, but it needs to be in counterclockwise of east convention. Measure in counterclockwise of east convention the angle with a protractor. There we go. So I don't have a protractor right here with me, so I'm going to say this is 300 degrees, and it's 3 kilometers. Okay. So that is it. We are done with 3.1a and 3.1b. 3.1b. Today you're going to work on the rest of the questions or the questions that are on Google Classroom. Tomorrow is going to be a work day, so this is one of those little sections like I talked about. So tomorrow is going to be a work day where you're going to do 3.1a and 3.1b review questions. And you're also going to need to do a reading, but I'll explain all of that tomorrow. For the rest of the period today and for your homework tonight, you're going to complete those questions, those 3.1b Part 2 questions that are on Google Classroom. And if you have any questions about any of this stuff, please let me know. And that is it. Have a good day.